Hi everyone, so in this video we are going to be looking at the SQL equivalents of the relational algebra that we've seen. To be precise, we'll just be looking at the very general syntax of SQL queries and the cross join and probably the union operator, but that's it. We'll discuss the rest in the next video. So before we start, I just want to tell you that I've modified the tutorial DB that we had. So let me just do a show tables here, and let me just run this query on tutorial DB. And right here I've got regions, countries, capitals and major cities. That's the tables that I have. So this regions actually just contains the continents, and then there are countries in those continents, and then I've got a table with a country and its capital, and major cities gives me the major cities in some of the countries. So the most general form of actually, before the general form, let's just look at the simplest relational algebra query that we saw, which was just the name of a relation. So I can do just regions, and that would be a valid relational algebra query. But in SQL, the way we do the same thing is to say select star from regions, and when we say select here, it actually means the project operator that we've seen in relational algebra. I know it might be a bit confusing because the select there's a select in relational algebra as well, and there's a select in SQL as well, and they don't mean the same thing. But what this query right here means is when I say star, it means everything. So select everything from this relation, which is called regions. So let's go ahead and try running this. And as you can see, I've got all my regions here. The first one is has a region ID 1, and the name is Asia, and then I've got all the way up to 5, which is Australia. So that's the simplest SQL query that I can have. And next, let's just look at the general form of an SQL query, which would be so there would always be a select clause, there would be a from clause, and there would be a where clause. And here we've just skipped the where clause, and the where clause is actually where we put the condition. So that's actually what corresponds to the select operator from our relational algebra. So what I can say now is select star from cities, or actually countries, where region underscore ID equals 1. So what I'm saying is select the countries from Asia that I have in my countries table, and let's just go ahead and run this. As you can see, I've got 4 countries here, all of them corresponding to the region ID 1. So that's how we can do it, and let's at this point just look at the union operator. So let's copy this, and let's get rid of the semicolon. What I can do now is I can say union, and then I do select star from countries where region underscore ID equals 2. So let's try running this one now, and as you can see, I've got my region ID 1 and region ID 2 right here. And of course, another way to write this same thing that we've done with union is to do it this way. We could just say select star from countries where region underscore ID equals 1, or region underscore ID equals 2. This or is valid SQL keyword, so I can run this and get the exact same result right here. And you might have noticed that the order in which I get my results is not fixed. So when I ran this query, I got all my ones first and then my twos, and when I'm running this, it's giving me uh, some mixed ones and twos right here. So basically when we run SQL queries, it doesn't give me the result in a particular order as such. The order is not relevant to us except if we actually sort them according to some attribute, which we'll see in some later video. But other than that, there is no ordering as such. And another thing to remember is that in SQL I would get duplicates as well. So if some query returns some row twice, it actually gives me the row twice. Whereas when we go to relational algebra, that's not the case. Relational algebra just says that eliminate all duplicates, and this difference arises because relational algebra is based on the set theory, and SQL is based on the multi-set or bag theory as it's called. So this ordering and duplicates is something that we should remember when we are working with SQL. And we haven't really seen this OR operator in our relational algebra, but we can just use OR like this. We just denote OR like this, and like this. So that's how we can use these in relational algebra as well. So next up, let's look at the cross join. So here I'm looking at the cross join now, and the way to do a cross join between, let's say, regions and countries is I can say select star from regions, join countries. I can just say join and it'll do a Cartesian product or a cross join for me. So I can say select star from regions, join countries, and that's it. Let's just run this query right here, and as you can see I've got a huge table here, because what it does is it takes every entry from the regions table and it maps it with every entry from the countries table. So I've got Asia mapped to Australia, then Europe mapped to Australia, then North America mapped to Australia, and so on. So this doesn't make too much sense right here, but this is how the cross join is done, and it's often very useful. And another way to do the same thing would be to say select star from regions, comma countries, and this gives me the exact same result. Let's take a look at this as well. So this gives me the exact same result that I got when I ran this query. So that's how I can join two tables. I can join them with this comma or the keyword join, and I can also have a where clause right here. I can also say where region underscore name equals Asia, and let's try running this now. And as you can see, I've got all mappings of Asia, and as you can see here, Asia is actually mapped to every country that I have in my countries table. So that's how this cross join is working. And also take note of the fact that the region ID is being printed twice, and that actually makes sense in this case because this region ID is not the same. This region ID right here corresponds to the regions table, and this region ID right here corresponds to the countries table. So Australia actually belongs to region 5, and Asia is region 1. So that's what these two region IDs mean. But one thing to take note of here is that if I say select region underscore name comma region underscore ID, let's say I just want these two columns right here, and I try running this is going to give me an error because it says column region underscore ID in field is ambiguous. So what that means is that this region ID is present in regions as well and in countries as well. So which region ID do you want to be printed? So I can say something like countries.region ID, and if I run this now, it says Asia and then 5. Again, this doesn't make too much sense to do to run this query, but I just wanted to point out that it gives this ambiguity error if I just say region ID without the countries part. So that's how we do the cross join, and we've looked at the union operator, we've looked at the cross join, and we've looked at the basic syntax of SQL queries, and we'll look at natural joins and the other operators that we've talked about in relational algebra in the videos that follow. So I'll see you there.